Yeah, so everyone can see my screen, I hope.
Yeah.
Okay,
Exactly.
cool. So let's show the first slide. So hi everyone, my name is Anastasia and I'm backend developer. Today I will be presenting how the backend of Lockton One works. We will discuss what is QBFT, how to write Genesis file, then I show you validator's demo, and after that I'll tell about airbag system in our project and the permission deploy. So we use QBFT, which stands for Quick Byzantine Fault Tolerance, a consensus algorithm implemented by Besu. QBFT ensures that all of nodes in the blockchain network reach an agreement on the blockchain state even the presence of faulty or malicious nodes. One of QBFT's key strengths is ability to tolerate faults. It can handle up to 1/3 of nodes being faulty or malicious without compromising the security or stability of the network. Basic Genesis file contains 3 types of parameters. It's network configuration, the Genesis block, and the milestone blocks. The most important ones are network type, QBFT in our case, and the transition, which we'll discuss later. In the Genesis block, we can specify parameters such as a lock, which predetermines the balances of accounts. Milestone block define the protocol of the version of the network. QBFT has 6 parameters of Genesis block itself. For demo, we use only the required parameters, all of which are on the left side, such as block period seconds, request timeout seconds, and epoch length. QBFT supports transitions, which allow you to specify a future block number in an existing network. You can update parameters like block time, block reward, validator management method, or mining beneficiary at a specified block. To make transition work, we need to stop all nodes in the network, update Genesis file, restart all networks in the network, and the changes would be seen in logs in the validators. I want to say a little more about validator management. QBFT provides 2 methods for managing validators. Block header validation selection, when existing validators propose and vote to add or remove validators using dishonor PCIP methods. And contract validator selection. Use smart contract to specify the validators used to propose and validate blocks. Currently, we're using the first method, which I'm going to demonstrate next. So let's move to validators demo. First, we should start our validators. Yep. Just hide this and start our 4 validators. Yeah, they should run and connect. One moment. CPU is 100. Yeah, it's starting. Now it started working. It should connect. Yes, they connected, and the block are mining. Let's see how we can deploy smart contracts. I have one moment. Container with contracts that we are currently using in our project. So we need to wait till core contracts compiled. And after that, we could see, yep, they compiled and start and deployed. Let's see our blockchain, we see that, for example, on block 53, we have one transaction that was successfully proceed. So what should I do if I want to become a validator? What happens if I just start my own node? Yep, it started, but validators still 4. And as we can see, in validators 5, they connected by, but did not, it is not a validator yet. We just see that we have only 4 peers, only 4 our validators. So for the to be validator, I need to ask the majority of validators to propose me as a new validator. Each validator has its own RPC. As you can see here, for example, it's 45, 55, 48, and for each is each of them has 1. Like here is 85, 45. So for proposing validator, we need to call the method that propose validator from this RPC. Yeah, it was proposing, but the validators still 4 because we need the majority. Let's make 3 of 4th validators. Yes, and then yes, here it is. There is my address, and we can see that we change a validators list, and now we are validator. Now let's dive into airbag system or role-based access control. I'll show you the configuration of roles in 1 second. And then Kirill and Nikita will demonstrate how to work with airbag on practice. For specifying a role, we need to assign a role name, then specifying the resources and defining the permissions for those resources. For example, corporate role, which has ability to deploy ERC20 and mint tokens, and verified on other side that can only transfer tokens. Now let's move on to permission deploy. The logic is behind is straightforward. A user must have permission from the admin to deploy a contract with specific bytecode. On the backend side, we have an RPC wrapper that enforces this logic. There isn't much more to it. Nikita will walk you through how it works in practice. So that's it. Thank you for attention, and let's move on to smart contracts.
Yeah, hello everyone. So I'll share my screen in a moment. And yeah, my name is Kirill, and I'm Solidity developer. So I'm going to tell you about contracts and how on the lowest level they work. So we will discuss the core of them and some additional modules. First of all, there are 2 core contracts within the system, and one of them is master contract registry, and another one is master access management contract. And everything in the system can be represented by this smart contract itself. In our case, master contracts registry serves a role of a place where all contracts are stored. So in our case, it could be any additional module. It could be reviewable request contract. It could be token factory. It could be another token. It could be anything that can be represented by the contract itself. This registry is based on the standard. It is YIP 6224 standard, and it describes how contract registry should function. And on this diagram, for example, we see that every entry, every contract that is added to this registry should follow the dependent interface. And basically what it allows us is to easily kind of scale our system and, for example, resolve circular dependencies. In case when we have, for example, token factory and token registry, and they depend on each other, and to initialize them correctly, we use this inject dependencies functionality to basically set addresses of each other to in their state. Yeah. And also, we have another contract, another core contract, and this is master access management contract. It is based on RBAC contract, which basically specifies a core permission functionality within the system, and it defines some generic roles, some resources, etc. And with it, you can define who is able, for example, to inject dependencies within your contracts, who can update your contract, or, for example, who can add contract to the system. And for each of those actions, you have to have specific permission. For example, to add a new contract to the system, the address that will do that, the account that will do that, should have create permission. And yeah, by default, in the very beginning, the deployer of the system has a master role, which can grant new roles, revoke roles, and access any resource within the system. By the resource, I mean that basically each contract is represented by a specific resource. Let's take an example of reviewable request contract. So this entity allows you to make two-stage execution. So for example, when a user requests something, it could be token deployment or something else. And after that, admin reviews this request and executes it if it is kind of good enough or something like that. And also, as we can see, this contract is a part of the system, and it follows abstract dependent interface, and it means that it has this set dependencies function. And here we see that master access contract initialized via this dependency injection process. And let's take another example of contract of the module within the system, and it is a token factory. So it allows you to deploy any number of ERC20 tokens, as well as ERC721 or NFT tokens. So here also we see the similar pattern. So firstly, user can request deployment, or if user has sufficient permissions, he can directly deploy ERC721 token on the blockchain. So the same logic applies in the token registry. So if you want to add new ERC20 token implementations, or you want to extend with some custom tokens, you can basically set their implementation. You can, after that, upgrade token factory contract itself via contract registry. So as I mentioned and showed, via this contract registry, you can also upgrade your own contracts, and then you will be able to deploy new contract or new token in your system. Yeah, so after that, we can move to yet another example. Here we see allowed contracts registry. It also integrated into RPC that it basically, this functionality allows you to permission contract deployment in the system, and only if contract was whitelisted by an admin or other operator in the system, only then this contract can be deployed. And after the contract is deployed, this kind of hash can be toggled, and that means that user will not be able to deploy this contract again with similar hash. Yep. And also another thing that helps with development and user experience is subgraphs. They help us to retrieve necessary data from the blockchain much more easily. So in case of airbag system, it's quite expensive, and we cannot store all of the data on the blockchain. We have to have some off-chain kind of indexer part that will help us to retrieve all of the data from the contracts. In our case, when we do grant roles, we can check easily user roles, but we cannot retrieve how many users have this specific role. For example, create role or admin role. And this graph helps us with this task. Basically, it stores every user, every role, etc. And then we can just make ordinary GraphQL requests and just retrieve the data. The same, we can see that we also have some data for reviewable requests. So it just improves user experience and makes development much easier in this regard. Also, a few words of the future. If you need, for example, account abstraction sync or something like that, you can just deploy new contracts on the chain, and after that, integrate them within the system by calling add contract or add proxy contract functions. And what it allows you is to scale your system. And also, in case of account abstraction, you could have recovery mechanism that is deeply integrated within the system. You could have reviewable request to recover account in case if the key pair has been lost or something like that. So it allows you deep and flexible kind of foundation of managing your system, of managing accounts and managing contracts within it. So it also can be integrated with off-chain tools, for example, RPC wrapper, and basically just manage your system as much as you want and shape it as much as you wish. So yeah, this is it regarding contracts part, and I will pass my word to the front-end part.
Hi everyone, I am Nikita, front-end developer, and I'm going to show the UI UX part. 1 second, share my screen. Okay, we are now on the MetaMask login page. Tries with MetaMask. We can see that no functions are available to us now because our role is unverified. There is also no information about us here. Try to QAC procedure to get corporate role. Now we store the data in the storage on the backend and send transaction to the smart contract to create a reviewable request. Awaiting transactions. Okay. Next, switch to admin and go to admin login page. Okay. Try to add a new admin. The admin was successfully added and displayed the list. On the request page, we see a pending request. Let's view and approve it. We send transaction to the smart contract, which means we have approved the reviewable request. Success, and next transaction grant role corporate to user. Success. Okay. Go back to user account. We can see that our role has been changed to corporate user, and account information is displayed. We try to deploy the token contract. It is possible to change permission for the contract for the different role. The token is deployed and displayed in the token list. Try to mint it. The token is successfully minted. Let's try to send it. Success. Okay. Go check the wallet to which we sent tokens. The tokens are here. But since this user is not verified, he cannot send tokens. It's the same QSC procedure, only now for default user, not corporate. Waiting for a transaction on a smart contract. Okay, successful. We try to switch new admin's wallet and approved QSC request from new admin's wallet. New QSC request. Approve. Let's check user account. After verification, the user can send tokens, but cannot deploy and mint. Try to send. Success. Okay, now we will move to another page and try to deploy mock contract. Okay, deploying your mock contract with this bytecode. For deploying contract, because admin did not allow us to deploy contracts with this bytecode. Click this bytecode, add the bytecode to the form to allow the deployment of such contracts. And after this, try to deploy this mock contract. And we successed. Thank you for your attention. I now pass the floor to Visrion.
Hello, everyone. 1 second. I'm going to show you demo in Figma of our platform that we want to build for the production version. Let's start from the web client. As an entry point to a client will be the sign-up page, and there we can see that we allow user to use two options for the sign-up. The first one is a common web 2 option as email with the password, and the second one option for the sign-up is the using some extensions of wallets like MetaMask and Lockton One wallet. Let's use the first one option. So we enter the email, password, create an account. Of course, we should validate our email. For it will be used some backend service that sends a message with a one-time password to the email. And actually, that's all for the sign-up page. What we can see at the web client of the Lockton One is the big portfolio page. That is the main page where we can find our balance of account, some stats about the price, percentage ratio of our tokens, the tabs for NFTs list, endorsements, and the history. On the left sidebar, we can see some tabs like a bridge, application page, and here we left some example tabs for the future improvements, and etc. Let's see what is my NFT page. There are the same with ERC20 tokens. We see our collection of NFTs. The page of endorsements and history is the simple pages. Endorsements needed for the account abstractions endorsements. When we give access to our I don't know, the balance for some application, we should see for which application and what exactly we allow to it, and maybe to revoke. About the history, I want to say that this is the common history that you can see at some explorers, blockchain explorers. So let's move to the next page, is the page for the bridge. Here we can see that we can choose the chain from which we want to send tokens, let's say from Ethereum. We need to connect MetaMask. Yep, the second chain, the second step is we choose the chain of destination. For the demo, we will choose Lockton One. And the search step, we just confirm the sender's address, select some token amount, and input receiver's address. After I confirm it, my transaction sends to the backend, which is works with a set of smart contracts that we will deploy, and just send tokens from one chain to another. Let's move to the application page. There we can see the list of applications that were deployed on Lockton One chain. There's some description, small information and its name, tags of application. This tags mean like DeFi, swap, etc., to give opportunity for the user to find what exactly he wants. By pressing on the application, there will be open a model window where we can see more detailed description, smart contract address, token, and eligibility of our account to use this application. This eligibility is based on our role, our permission, the smart contract role, how the smart contract integrated with our system, etc., etc., etc. So for the web client, that's all. And I will mention that we have the KYC procedure, as you will see in the demo of UX of Nikita. So let's move to the admin page. Admin page welcome us with the sign up. And so here we can use two options like MetaMask wallet or Lockton One wallet, but it's similar. Let's use MetaMask. As we can see, the admin panel looks like this, and it consists from 5 pages, KYC requests with the request for KYC from the users page, where we can find the list of administrators, users, manage their roles, etc., etc., etc. Application page, from which we are creating the applications that we will see here. The ecosystem page is the page with information about our another chains that were deployed using a rollups technology. And the assets page is the page where we can create new assets by using Token Factory or adding some another tokens. Let's see how will work every page. For example, here we can see the KYC requests. We see the address from which we received this request. We see the roles that the user wants to achieve, the date, and the status of the request. New user and update. New user means that this user created his account, and this KYC request is the first one from this account. Let's see how it will look like. Here are user's address, some information about requests, 2 buttons, approve and reject, and KYC data. So administrator could download, check every field, and be sure that it's all okay. Let's approve this request by pressing the button. There we can choose the expiration date of our KYC, which allows us to set some date when the KYC will be revoked and the granted role will be revoked too. It will work automatically by backend service that will check every day if their KYC requests are expired. Let's confirm. Yes, we approved our request. Let's move to the user page. There we can see the list of users, but it's not the kind of typical users. It's our list of administrators, which allows to administrators see firstly his colleagues. So as the users, administrators will be able to use airbag system role base. And it is possible to create as many roles of administrator as we want. For example, here we can see that we have master admin, we have KYC admin, and the asset admin. master admin has permission to every smart contract, every resource on the system. Asset admin has permissions only to the resources which are related to assets, and KYC admin has the permissions to resource that are related to KYC requests, blocking users, etc., etc. Let's find the common user using the search bar. And here, as we can see, we find the user with his KYC data. Zara is the same as KYC request, not the same, pretty similar. User's address, his roles on the Lockton One, we can see that he has a corporate user role. And Zara, we can see the roles that were granted on another chain's rollups. So on another chain, he has a master admin. On another chain, he has the asset admin roles. And below, we can see the KYC data that he provided on the Lockton One through the KYC request form. Let's block this user because I don't want to see him in our system. Yeah, it works. Let's move forward to the application page. And there we see our created our applications with text, its name, date, etc., etc., etc. Let's add one new one. We need to fill out the form with application name, smart contract address, owner address, description, choose a text, etc., etc., etc. To be sure to give users opportunity to look through this information and just show it. The next step, it's optional and can be used or not. This step required from administrator to add some new resources and permissions to our airbag system, which means we need to create a new resource and permission in our smart contract. Why it is needed? Because we have two types of integration our system with new smart contracts. For example, the first type is when the creator of smart contract integrates it on himself side, like writing code in smart contracts that already works with our system, or he won't do it, and ask administrator to add some permissions, some global permissions to users. Let's try to add new resource and divide some action. Let's move to the next. The next step for creating our application is the set of level of trust. Level of trust defines based on the risk level of account. We have 5 risk levels, which means that the higher risk it has in the form of money. So the lowest amount of application will be able to use. Let's say check out and define. Yes, on the step 2, we decided to create a new resource and write actions to this resource. So now we should add to our global roles these permissions related to this resource. To verified user, we grant action 1, action 2. For corporate, action 3, action 4. For example, it can be send or receive, I don't know, tokens. For corporate user, it can be execute, mint, etc., etc. So we press confirm, and our application is created. Now we can look through the application, check some information about it that we were inputted. There are some description, text, etc., etc., etc. We can see our roles and permissions that we set it before, and we can block application to grant a blocked role to this application that forbids users to use it application or edit application, which means we will edit every field of our application. Okay, let's move forward to ecosystem page. Ecosystem page consists of many chains that were built on top of Lockton One. For example, chain name 1 is the ZK rollup with the permission public. It's the page of this rollup, and this information will be helpful for Lockton One administrator to properly manage his system. Yeah, there we can see the list of administrators, their addresses, their roles. We can see the roles of this chain. For example, KYC administrator could use this. Okay, let's move to the next page, and this is the assets page. There we can see the list of assets that were deployed by administrator. For example, it can be used for some bridges. Let's imagine that we want to bridge some tokens like Doge coins from Ethereum to our Lockton One. A network, so administrator just create a new wrapped Dogecoin and connected it with bridge. Let's see how it looks like with the assets. There are some general information about token, its symbol, supply, address of the owner, white paper, and the roles if it presumed. So let's create a new one. There are just 2 steps. On the first one, we need to provide a general info. Token name, symbol, max supply, token description, owner's address, logo, and white paper if it is required. On the next step, we could define the roles for our users. For example, the verified roles should be able to send assets or receive them. Or this step could be just skipped. Yep,